Hey guys, and welcome to Solving Linear Inequalities. Today we're going to not only solve the linear inequalities, but we also are going to practice graphing them on a number line and doing interval notation. So there's a lot of good stuff in here. Our first example that I have for you guys today is 8b plus 3 times parentheses b minus 12 greater than 7b minus 28. So solving inequalities is almost identical to solving equalities or equations, which is kind of like one hitch at the end. And it's just, well, did you divide by a negative or did you not? Otherwise, we can kind of play the same game here. So we can keep this 8b. Let's distribute plus 3b. 3 times negative 12 is negative 36. Greater than symbol stays because we haven't divided by a negative. 7b minus 28. Alright, and let's see, we got an 8b here and a 3b here, so let's combine that to an 11b minus 36. This is all still greater than 7b minus 28. Alright, let's get all of our b's on one side. So let's subtract 7b from here, and we're going to subtract it from here as well. So that's going to give us 4b minus 36. And we'll have a negative 28 hanging out here on the right. Alright, so see, same thing. We've been going through and solving this the same way we would just solve E equations. So let's get rid of the 36 by adding it on both sides. And we end up with 4b greater than, we still haven't divided by a negative, negative 28 plus 36. This is going to bring us out to a positive 8. Divide by 4, divide both sides by 4, and we're going to get b is greater than 2. So what this means, and let's think about this in words, we want all numbers such that they're greater than 2. So if we go down to our number line, here's 2. We want all the numbers such that they're strictly greater. So 2 is going to get an open circle because we don't want to. We want to be strictly bigger than 2. And if we want all the numbers bigger than 2, we want 3, 4, 5, 6, 7, 8, 9. So we want all of these numbers here, and then let's take that out to infinity. So with that in mind, so we wanted 2 to be our smallest number. So for interval notation, right, we either have parentheses or brackets. The small number goes on the left, the big number goes on the right. So if we want all numbers such that they're bigger than 2, then 2 is going to be our small number. So 2 is going to be on the left. And we're not including 2. We want it to be strictly bigger. So that's going to get the curved bracket or the parenthesis looking guy. And now if we look down at our number line, we go all the way off. So we want 8, 9, 10, 11, 12. And I can literally be counting forever, which means I want all the numbers as they go to infinity. And now infinity, we never actually get there. I know in Buzz Lightyear says to infinity and beyond, but we'll never actually get there. So since we can't actually ever get there, we get a curved parenthesis there as well. So solved out, we get b greater than 2 on a number line, open circle on 2, arrow out to the right, curved parenthesis at 2 on the left, comma, go off to infinity on the right with a curved parenthesis. So let's try this again. So on a different example, and let's go back to pencil. So what about with this guy? So seemingly similar, but instead of greater than, we have a greater than or equal sign. So let's see how to kind of deal with that. So we kind of go about our business. Let's solve this as we know how to solve. Negative 2 times y, negative 2 times positive 6, will give us a negative 12, greater than or equal to negative 5y minus 24. Alright, negative 9y minus 2y. We're going to go more negative, so we're going to get to negative 11y minus 12, still greater than or equal to negative 5y minus 24. Alright, let's get all my y's on the same side. So let's, oops, sorry, that's supposed to be a 5. So let's add 5y here. I'm getting ahead of myself. Add 5y here. Negative 11 plus 5. We're going to go 5 in the positive direction, so that'll land us at negative 6y minus 12. This is greater than or equal to negative 24. So I got all my y's on one side, which is great, but now I need to clear out this negative 12, so let's do the opposite by adding it to both sides. So I still have a negative 6y. Always remember, carry those negatives with you. Still have a greater than or equal to. Negative 24 plus 12 will end us at negative 12. And now, here's the big thing. I'm going to divide by negative 6 on both sides. Notice I divided by a negative, so I'm going to get positive y. When I divide by a negative, my sign needs to change direction. Negative divided negative is positive. So now I want all numbers that are less than or equal to 2, whereas before I divided by the negative, it would have been greater than or equal to. But dividing by a negative switches the direction of the inequality. So now I get y less than or equal to 2. Okay, so I have an or equal to, so I can go to my 2, I draw a circle, and because I have an or equal to, 2 is actually an okay number to have, so I'm going to fill in that. So I want all numbers such that they're less than or equal to 2. So let's find all the numbers less than 2. Oh, 1's less than 2, 0 is less than 2, negative 1, negative 2, negative 3. All of these guys, right, are less than 2. And actually, let's just keep going till negative infinity. So all numbers less than 2, we get to take 2 because the or equal to, and we get to go down to negative infinity. So our interval notation, now 2 is the biggest our number can be. So 2 now is going to go on the right. And we can be less than or equal to 2. So 2 is now going to get a square bracket. So I want all the numbers such that they're less than or equal to 2. So I want 1, 0, negative 1, negative 2, negative 3, negative 5, negative 10. I want negative 100. I want all the negatives. And I could keep going down to negative infinity. And we don't ever get to infinity, whether it's positive or negative. So we get a curved bracket here. So our inequality solves down to y less than or equal to 2. So 2 is the biggest we can be. We want everything less than on the graph. So negative infinity is going to be our smallest, comma, and 2 is the biggest, and we can include 2, so it gets a square bracket. So let's do this again. But of course with a different example. Alright, so let's see what's going to happen here. And let's go back to pencil. Alright, so seemingly similar problem. Again, we have a less than or equal to. So let's see what's up with this guy. So 8x, negative 2, positive 5, that's going to be a minus 10. Negative 2 times negative x, so I'm just distributing, that's going to be positive 2x, right? Negative times a negative is a positive. Less than or equal to 10, I'm distributing 10 times x is 10x, 10 times negative 1 is negative 10. Alright, let's combine some like terms. I have an 8x here, and I have a positive 2x here, so that's going to give me a 10x, and then the minus 10. Less than or equal to 10x minus 10. Oh, this is something weird is happening, but let's stick with it. Let's kind of keep going. Okay, I want all my x's on the same side, so I'm going to subtract 10x. I'm just going to kind of keep going, keep playing it cool, see what happens. Well, let's see. Those guys cancel, so I end up with negative 10 less than or equal to negative 10. Oh, I've run out of variables. What happens? Okay, so you evaluate your statement. So what the heck? We evaluate our statement. Is negative 10 less than or equal to negative 10? Is that true or is that false? Well, that's true because we have the or equal to. Yeah, negative 10 is equal to negative 10, so technically this is true. So this is true. So if you solve something out and you get rid of all your variables, you decide, well, is the end result, is this true or is this false? Well, in this case, yeah, this is fine. So what's going to happen here? This is going to be an all real numbers. So it doesn't matter what number I plug into x, I will always get a true statement. So what I do on the number line, hey, because it's all real numbers, this is kind of fun. I get to scribble down this way, and I get to scribble down this way. In other words, I want the whole thing. I want all the numbers. So I want the whole number line. So I'm going to spill out the whole number line, draw arrows on both ways. So what's my smallest endpoint? Well, I can go left all the way to negative infinity, and I can go to the right all the way to positive infinity. I want all the stuff. Okay, so if you solve something down and you get a true statement, it's going to be in all real numbers. You want all the stuff. Your interval notation is going to be from negative infinity to positive infinity. And your number line, you get to color in everything, and who doesn't love to color all this stuff? Alright, so let's see what happens if we are in a different situation. And we have fractions, because who doesn't love fractions? Alright, what do I do when I have fractions? This is like everybody's least favorite thing. So let's make this really big, and let's choose a really fun color like yellow. Alright, so look at your denominators. There's a denominator, there's a denominator, there's a denominator. So we look at all the denominators. I'll go back to my original, my green that I really liked. Let's see, there it is, bright green. So we take all the denominators and we find the least common multiple of all of them, or otherwise known as, if we had all these denominators, what denominator could we create with a common denominator? In this case, if you notice, 4 will divide 24 evenly, 8 divides 24 evenly, and 3 divides 24 evenly. We're in kind of a special case. So here, the LCM is going to be 24. If ever one of your numbers is the kind of multiple of all the other ones, or you notice all these numbers divide one of the numbers, that big number is going to be your LCM. Alright, so what we're going to do with that, we're going to take our LCM and we're going to multiply it by every single thing in here, as long as it's not in parentheses. In our case, none of it is, so we're good. Let's see, this guy's going to get a 24, and this guy is also going to get a 24. Okay, I'm sorry, the A could have been inside the parentheses or out. It doesn't actually matter. Okay, so now we get to blow out denominators and get rid of our fractions. This is the best part. Okay, 24 divided by 3. Those blow out to become an 8. Awesome. 24 divided by 8. Those blow out to become a 3. So we're going to sneak my 3. I'm going to sneak my 3 kind of in here. So the 3, those guys got blown out. The 3's out here. 24 and 24, boom, just blow each other out nice and even. And then 24 and 4, these guys blow each other out to be a 6. So they divide. When I say blow out, I mean divide. Okay, so what's left over now? Now we got to kind of pick up the pieces and see what we got. Alright, 8 times 1 is 8. And all of your variables are just going to come for the ride because we didn't cancel out any variables here. Alright, our 24 and 8 divided out to be a 3. So 3 times 1 is 3. And there's a minus sign in here. So it's going to be minus 3a. We haven't divided by a negative, so that's going to stay. 24 and 24 blown out completely, so we get 5a. And 24 and 4 divided out to be a 6, so we have 3 times 6 up here to be 18. And there's no a here, so we're just going to take the 18. Hey, that looks way better to deal with than the previous problem. No more fractions. Always blow out your fractions. Always clear your denominators. Alright, 8, it's not hard to say, 8a minus 3a will be 5a. Is 5a greater than 5a plus 18? Ooh, something weird's going on again. Alright, let me get all my a's on one side. Oh, shoot. 5a minus 5a is 0. It's not 1 or a, it's 0. Anything completely minus itself is 0. Oh, shoot. Okay, so we're in another what the heck does this mean situation. Okay, so now we ask, is this true? Is 0 greater than 18? No way, man. No chance. Not any day of the week, right? If you have $18 or you have $0, I want the $18 because it's more. So this is false. So because false, that implies that there is no solution. In other words, it doesn't matter what I plug into A. I can't plug anything into A to make this statement true. There's literally no solution. There's nothing I can do about this thing. It's just not going to work. So we have no interval notation because there is no interval